Okay, so we're doing bounded area, but we're taking it one step further. Okay, so the problem says consider the area bounded by the functions y equals 6 and y equals x squared minus 4x plus 1. Okay, they want you to find a value of k such that x equals k divides the bounded area into two equal parts. Okay, so let's deal with this at one piece at a time. Okay, so it's always better to kind of sketch what you're dealing with while you're working a problem. So I'm considering this area bounded by these two functions right here. So the first thing that we should kind of do is sketch what those functions look like. Well, we know y equals 6. That's just a horizontal line. Okay, so this is y equals 6. And then this one is just a quadratic. Opens up, it's going to have 2x intercepts, so it's going to look something like this. Okay, so basically this area that we're talking about is right here. This is my bounded area between these two functions. Okay, now I don't even need to know what that area is, okay, at this moment. All I need to know is that that's what my area looks like. I've got a quadratic and I have that horizontal line. Now, it says find the value of k. K, we use the letter k for basically just a constant. And we're going to find x equal k that divides this area into two equal pieces. Okay? X equals k, this is a vertical line. Okay? So basically, there's going to be some vertical line here, x equals k, that's going to divide this whole area into two pieces that are exactly the same area. Okay, that's what this problem is basically asking us to do. Okay, now most of my students, the first thing that they would do is they would find the total area and then divide it in half. But that's not anywhere near what this problem asks you to do. Okay, it didn't ask you to find half of the area, it asked you to find the line that would divide it into two equal areas. Okay, now as soon as you hear bounded area, you know you're dealing with the integral. Okay, so we've dealt with basically two concepts all year long. We've dealt with the derivative and we've dealt with the integral. The derivative mainly deals with slope, okay, rate of change, maximums and minimums. When we deal with the integral, we're dealing with the antiderivative and we're dealing with areas or volumes. Okay, so those kind of clues basically tell you what you need to do. Now, of course, we are doing bounded area right now, so obviously we're going to be using the integral. Okay, and remember, the integral itself means area. So this part right here is the main clue on what you're going to do. Is that you're going to have two equal parts. You're going to have one area that's going to start here and end here, and then another area from here to here. And those are going to be equal. So the first thing we're going to do is find our points of intersection. So how do you find where two functions intersect? You set them equal to each other. Which is kind of, one of those moments where you're like, duh. When you want to find where two things are the same, when we talk about things being the same in mathematics, we talk about them being equal. So if we want to know where two things are exactly the same, we set them equal to each other. Okay? So when we do that, move the 6 over, we get x squared minus 4x minus 5. Factor it. Factors as 5 and 1. This is minus, this is plus. So x equals -1 and x equals +5. So those are our intersection points. So this is at x equals -1, and this one is at x equals 5. Okay? That means my first area starts at -1 and ends at some k value that we don't know. And then the other area is going to start at k and go to 5. And we know that those two areas have to be equal. So basically, we have this going on. The area from -1 to k, 6 minus x squared minus 4x plus 1 dx. So this is the area from -1 to k, and it has to be equal to the area starting at k and going to 5 using the exact same equation. Like that. And that's what this says. It literally says that the two areas, one area from -1 to k and the other area from k to 5, have to be equal. And that total area from -1 to 5 is the whole area. So there are a couple of ways you could do this. If you wanted to, you could find the total area and you could put those two on the same side and set it equal to the total area, which makes it more complicated. Or you could say that the total area minus one of those equals the other one. Or you could find one in the total area and set it, like multiply it by 2. There's a bunch of different ways, but this is basically the easiest way, like this. Okay? It's the most straightforward. So at this point, we're just dealing with two definite integrals. So just evaluate them. So I'm going to simplify a little bit. So from -1 to k, and this ends up being 5 plus 4x minus x squared dx equals k to 5, same thing, 5 plus 4x minus x squared dx. And what makes it really simple is on both sides, these integrals are going to be the same, the antiderivatives and everything. So we take the antiderivative, and we get 5x plus 2x squared minus 1/3 x cubed. And this one will be from -1 to k equals the same thing, 5x plus 2x squared minus 1/3 x cubed, but this one will be from k to 5. So the antiderivatives are the same, and we're basically going to evaluate them the same. The only difference is which one we're going to plug in first and which one we're going to plug in second. So here we go. So in this one, we're plugging in top k first. So we get 5k plus 2k squared minus 1/3 k cubed minus, this is -5 plus 2 plus 1/3. When we plug in -1. And that's going to be equal to, and on this side we plug in 5 first. So this is 25 plus 75. Yep. No, 50. I'm getting ahead of myself. 50 minus 5 cubed, which is 125 over 3, minus, and plug in k, 5k plus 2k squared minus 1/3 k cubed. Now, since these two are equal, I'm going to do a little algebra. Okay, okay, to make my life a whole lot easier. Instead of getting rid of my parentheses and moving everything individually, I'm going to move them inside the parentheses. For instance, I'm going to move this whole thing to the left side, and I'm going to move this whole thing to the right side to make my life easier. So what's going to happen is I'm going to have 5k, and this is going to be plus another 5k. So it's going to double my k's on the right side. So on the right side, I'm going to get 10k plus 4k squared minus 2/3 k cubed equals, and then here I'm going to get 75 minus 125 over 3 plus -3 plus 1/3 by moving it over. So now I can add up my like terms on the right. So I get 10k plus 4k squared minus 2/3 k cubed equals 72 minus 124 over 3. Now, we gotta solve for k. So which means we gotta get this thing equal to 0. So I'm gonna move this back to the right to get that k cubed positive. So I'm going to end up with 2/3 k cubed minus 4k squared minus 10k plus 72 minus 124 over 3 equals 0. Now at this point, since it's a calculated problem, now we're going to use a calculator, okay, to find our zeros. So if you have a calculator that you can plug this in and find the zeros, solve it for you that way, that's fine. If not, you could put that into a graph, find the zeros or the x-intercepts, okay? But you're going to get 3 of them. You're going to find that k can be -3.196 blah blah blah, k equals 2, or k equals 7.1961 blah blah blah. Okay, so those are the 3 values we get with k here. 2 of them we can't use because -3 and 7 are outside of my bounded area. My area is from -1 to 5. So my only value I can use is 2. So basically here we find that my vertical line is at x equals 2. So k is 2. So when looking at this problem, that kind of makes sense. If you had actually graphed our quadratic, you would have found that the vertex is at 2, at x equals 2. And since quadratics have symmetry, if you knew where the vertex was, you'd basically find the dividing line for that area since it's perfectly symmetrical. Okay? But again, this wasn't about using those tricks. It was to actually work through the problem to see how you find k. Because not every problem, the area will be perfectly symmetrical. Okay? If you had a pretty powerful calculator, like if you had the Inspire, the TI Inspire, you could have actually plugged in this right here into its solve function, and it would have solved it right there. And we wouldn't have had to do the algebra. If you don't have a calculator with an algebraic system, because this has a k in it, it won't solve it. So unless you have the CAS system or another calculator that does similar, you'd still have to get it to right here to be able to either plug it into a calculator of some kind. Okay? But that's just like the problem number 11 from our homework.